Alright everyone, welcome. This will be our final video on projectile motion. And this will be part 3. So now in this video we're going to be talking about what and how to tackle a problem if you're given something thrown off of a cliff at a certain angle. So let's just take, for example, our old soccer ball and just say we have our soccer ball and somebody kicks it, right, like we said earlier. Again, I'm not an artist, so just forgive me for that. Somebody kicks it, and we're going to use the same numbers that we used the last time. So they give it an initial speed of 15 meters per second at an angle with the horizontal of 50 degrees. So now these problems most of the time will ask you for the total time travel in air and the maximum range that the ball will achieve. So in order to do that, the formulas are a little bit different. So this ball will go somewhere here, probably a little bit higher, somewhere here, and then land right there, right? So then from the cliff to the end of the building, that's known as a range, or x, or distance traveled. Now in order to find that, well, from last video we know that that's going to be v naught x times our time, right? So we know our v naught x because if we break this component, this vector, into its components from our previous videos and vector videos, we know that that's going to be 15. Let me change colors. Yellow is too bright to be visible. It's going to be 15 cosine 50, and the y would be 15 sine 50. Alright, now knowing that, we're going to come back in here and plug it in. So here this will be 15 cosine 50 times our time. But oh wait, we don't know what that is. How can we find that? We're about to do that. Also notice how I have omitted the units. Remember in one of the videos I said carry on the units. I'm just omitting them because it takes more time for me to write them out and it makes the video longer. So I'm trying to make the videos as short as possible. So now here we're missing time. So let's find this time. So in order to do that, we're going to work with the x-axis like we did on video number 2. So now for the time, we're going to use the formulas that we used on video number 2 and 1 to derive the equation. So we're going to say y is equals to y naught plus v naught t plus 1 over 2at squared. Now remember, on Earth, acceleration is actually negative gravity, so this will transform into y naught plus v naught t minus 1/2 gt squared. Alright, and I forgot to give us the initial height, so I'm gonna say that's 10 meters. So now our final position, or height in this case, will be, and this is velocity over the y, will be 0 because it's the ground. So this goes to 0. Our initial position is 10 meters. So again, I'm going to omit the units. 10 plus v naught over the y. Well, that's 15 sine 50. So again, pause the video and do this on your calculator. Make sure you get the numbers I'm getting. So after putting that in the calculator, I got 11.5 times your time minus 1/2 g. G is 9.8, so 1/2 of that is 4.9 times squared. Now, in order to solve for t, for this equation, you're going to have to use the quadratic equation. It is a little bit painful, but we'll get through it. I'll walk you guys through it. So now let's go ahead. And the quadratic equation is going to be t is going to be equals to negative b plus minus the square root of b squared minus 4ac all over 2a. Alright, so now we're just going to plug in the numbers, plug and chug. Now just a real quick thing to point out. This 10 is our c, this 11.5 is our b, and this negative 4.9 is our a. And now you may be asking, wait, why? I always thought it was a, b, c. Well, remember how all this the quadratic formula is used when you have ax squared plus bx plus constant. Notice the x squared here, that's our t squared. So we just have this same format, but on the opposite. It's flipped. So that's why. So now after you plug that in, I end up having values of, let me move this upward. Now I end up having values of t equals to negative 0.675 seconds and 3.02 seconds. Now you may be wondering, what is this negative got to do? Like, time can't be negative. We can't travel to the past. And that's very true. So here, that's just saying, well, even before, this is not physically possible, but mathematically it is. So even before it was here, it was down here at negative time. So you don't really have to worry about what that means. So most of the time in non-calculus physics, we're only going to use the 3.02 seconds to do our calculations. So now we're going to go ahead and plug that in. So moving it upward was useless. So now we're going to plug this time because that's our total time traveled. So for the problem, this would be your total time traveled, the time it took to go from here all the way down till the end. And now to find the range or the distance traveled, it will be times 3.02 seconds times the 15 cosine 50, the x component of the velocity, and that gives you 29.1 meters. So that would be your range of travel, and it took 3.02 seconds. Now some problems may ask you what's the highest it was able to hit. I'm not going to cover that in this video. If you guys would like me to, hit me up. Just say you guys want to see a video about that. But I would say you can just refer to video 2 and 1. So just find what the distance is right here to the highest point, and then just add the 10 that you already know from here. And you can find this distance using the v squared equals to v naught squared plus 2a change on y. And then here it will be actually over the y, it would change to negative 2.2g, because remember, acceleration is negative g. Now all you have to do, remember, at the top your final velocity is 0. Just plug and chug 9.8 and find the distance that you travel, add it to 10, and you'll find that. Let me know if you would like me to explain that in another video. I hope this video was helpful. Remember to like us on Facebook and follow us on YouTube, and leave some comments below. Let us know what you think. Good luck in your study.